Welcome, and thanks to Dario, Travis, and others for inviting me to speak to you today. My name is Jeff Bennett. My email address is there. If you want to reach out to me at any time, feel free. My main goal today is to give you a few concrete examples of things you might use in your own teaching or outreach work when you're talking about global warming or climate change. In case you're wondering about my qualifications for talking to you, I've been teaching about this topic for some 40 years now, and here are some of the resources I've helped create and from which the examples I will give you come from today. For college classes, I have textbooks in astronomy and astrobiology, and also a book about science teaching strategies, all of which go into some detail on global warming. For the general public, I have this book called A Global Warming Primer, which is posted freely online at globalwarmingprimer.com. For middle school and high school students, if you go to grade8science.com, you'll find my free Earth and Space Science curriculum. Chapter 7 is devoted to climate change. For kids, I have a book focused on climate change called The Wizard Who Saved the World. There you can see it being read from the International Space Station by JAXA astronaut Koichi Wakata. I've helped develop this free app that you can download to learn about total eclipses called Totality, and it also includes a section on global warming. And I've been working for many years on developing scale models of the solar system, which you'll see how they play into teaching about global warming shortly. And you can learn more, including how to get one for your own community at voyagesolarsystem.org. So I hope I've convinced you that I have at least some qualifications for speaking to you today. And I want to turn now to the question of why are we as astronomers talking about this at all, when after all, this is not really our field. You might think climate scientists should be the ones going out and talking to the public about global warming. And of course they are, but there are some reasons why we're also very well placed to talk about it. First, while to us, these are different disciplines, climate science versus astronomy, to most of the public, we're just scientists just like they are, and that makes us qualified to speak on scientific topics. Second, in many ways, it is our topic. There's lots of aspects of astronomy that play into the science of global warming and climate change. I'll give you a few examples later, but for example, here, I've shown you one picture where you see how Earth's temperature has changed over the last few decades of the solar irradiance. And right here, you've basically got smoking gun evidence that it is not the sun, as some people have tried to claim, causing global warming. Third, we've got a lot of public interest in our topic of astronomy, and that gives us some credibility. As a quick example of that idea, just think about the fact that hardly anyone blinks an eye when we start talking about things as strange as black holes, and yet some of those same people question the science of global warming or the science of vaccines. So we can use their interest in our topic and our credibility to help them understand this topic as well. And fourth, I'll point out, especially for those teaching college in the United States, if you have students taking the general astronomy or astrobiology course, that is likely the only exposure to college science that those students will have. And that makes it very important that we cover this topic in those classes, because otherwise they're not going to learn about it anywhere else. I want to talk very briefly about some general principles when you're addressing a topic that can be sort of as sensitive as this. The first is to maintain what Travis Rector likes to call radical civility, which is just a nice way of saying that you should always be respectful and thoughtful with your audience, even when it seems to you that they might be unreasonable, because just arguing with each other is never going to get us anywhere. Second, make sure that when you're talking about this topic, don't only cover science and consequences, but also talk about what we can do to solve the problems that the science and consequences tell us are there. Talk about the solutions. And going along with that, I like to focus on the idea that we should be teaching with inspiration, not fear. And of course, that's a little bit subtle, but I'll give you Greta Thunberg here to give a great example of it and of why I put only in brackets here, because it is a scary topic. And as she says, I want you to panic. I want you to feel the fear I feel every day. But that's not where she stops. And then I want you to act. In other words, we must use the fear to inspire us to work together to build the kind of world that we hope we all will live in. I want to start talking about some concrete things you can do with different audiences now. And one of the first things I like to do is ask my audiences to think about the future. And of course, as astronomers, we're used to thinking about the very, very long-term future, millions and billions of years, but that's not the case for most of the audiences we'll be speaking to. For example, if you ask high school students, what are you thinking about when I ask you, what is the future? They'll probably be telling you they're thinking about college, and college students might be thinking about their first job, and so on. It's rare for people to think beyond a horizon of just a few years unless we really encourage them to do that. The same is true of the media. If you look at global warming reporting in the media, they'll often talk about the year 2030 or the year 2050, but rarely do you hear about anything beyond that. And yet, if you think about the kids who are in school today, or your kids or grandkids, depending on your age, these kids are very likely to be living well beyond the year 2100, especially when you consider that if advances in medical science continue, it may well be common for people to be living to age 100 by that time. And therefore, I want you to encourage your audience at the beginning to be thinking longer term, not just these short-term horizons of a few years or even just a few decades, but to the year 2100 and beyond. For kids, for example, I like to ask them to think about what will the world be like when they turn 100, and what will they say about what happened to the world from the time that they are at their current age till age 100, and what did they do to help make the world what it is at that point. Now I want to move on to what I mentioned before about the importance of talking about science, consequences, and solutions. And I'm just going to give you a few very brief examples of how I like to present these things. And I will start with the science. And for the science, being an astronomer, I think it's important for us to start with something astronomical. So I like to talk about what I call a tale of two planets. And what you see here on the screen is Earth and Venus shown to scale. And what you see immediately is that they're both about the same size. And we can tell our audiences from other planetary missions, we also know that in most respects, these two planets are very, very similar. They have the same general composition, the same general layering, and so on. Indeed, they're about as close to being identical twin planets as it's possible to get, with one major exception, and that is their global average surface temperatures. Pleasant for Earth, hot enough to melt lead on Venus. So I like to ask my audiences, think like a scientist. And as a scientist, when you see something like this, you should be saying, wow, that's really interesting. Why would two planets that are so similar in so many ways have this one major difference between them? And as a scientist, the next thing you might do is hypothesize. And the most obvious hypothesis is, well, Venus is closer to the sun. Maybe that explains it. But you can calculate the fact that it doesn't explain it. And in fact, you can qualitatively explain this to almost any audience using one of these scale models of the solar system, like I mentioned before. To do that, just imagine that there's a bonfire here at the sun, and imagine standing at the positions of Venus and the Earth. And sure, it's going to be warmer at Venus than the Earth because you're closer to the bonfire, but you can see that difference is not going to be enough for this big change. So distance alone does not explain the difference. So what is it? You could keep going with hypothesizing, but in most cases, if you have a relatively short time, I get straight to the answer, which is the greenhouse effect. Depending on your audience, you may need to take some time to explain the greenhouse effect, or they may already be familiar with it. For younger audiences or the general public, I like to use the blanket analogy. This is a picture from my book, The Wizard Who Saved the World. And the idea is that the greenhouse effect is like blankets for Earth. As you increase the carbon dioxide or greenhouse gas concentration in the atmosphere, it's like adding more black blankets that trap more energy and heat down at the surface, oceans, and in the lower atmosphere. Now, if we've asked our audiences to think like scientists, they might next be asking correctly, how do you know this is real? How do you know that this greenhouse effect that you say is the cause of the difference between Earth and Venus, how do you know it's true? And the answer is because we've done the work. We have laboratory measurements of how carbon dioxide affects and other gases affect light of different wavelengths. And we have the confirmation, real world confirmation of the laboratory evidence by looking at how the predicted and actual temperatures of planets compare, and finding that we only get the correct answers when we include the greenhouse effect as measured in the laboratory. Also worth noting, of course, that without the greenhouse effect, Earth would be too cold for life. This is the equation for calculating the temperature without a greenhouse effect. It would be below 0 Celsius. And that brings me to the summary of our tale of two planets, which is that Earth has enough carbon dioxide in the atmosphere to make our planet livable instead of frozen. Venus has so much carbon dioxide that it is absolute proof that it's possible to have too much of this good thing for life on Earth. And again, I've gone very quickly through that for you. With your audiences, of course, you would want to slow that down. Once you understand that the greenhouse effect is what makes planets warmer and that more greenhouse gas means warmer temperatures, then you next present the data showing that the greenhouse gas concentration in Earth is rising due to our burning of fossil fuels. And if you're wondering how can we explain to the audience that we know it's the burning of fossil fuels causing this increase, there's 4 basic reasons, 4 lines of evidence. They're all in my global warming primer. But the smoking gun is the carbon isotope evidence, where the ratio of carbon-13 to carbon-12 in the atmosphere matches the organic ratio expected from fossil fuels and not the inorganic ratio from volcanoes. You can also show the audience that we have data even going back before the direct measurements were being made in 1958. Ice core studies give us an 800,000-year record of Earth's climate and carbon dioxide concentration. Here I'm showing only the carbon dioxide concentration. Later in my talks, I won't do it today. Here for you, I would also show the temperature data and the ice ages that correlate with the carbon dioxide concentrations, ups and downs, ice ages and interglacials. But the point being, we see clearly that we have caused a huge increase in the carbon dioxide concentration. And that brings me to the main point of the science that I like to emphasize with audiences of any age. And that is that you often hear that Earth's climate is very complex. And it is. The climate system as a whole is extremely complex. But the basic science of global warming is not. It's very simple. I like to say it's as simple as 1, 2, 3. Number one, we know it's a fact that carbon dioxide and other greenhouse gases make Earth warmer than it would be otherwise. We know that through the evidence that I already showed you very briefly. Number two, it's a fact that the use of fossil fuels is adding carbon dioxide to the atmosphere. Again, the evidence I've shown you with the graph of the rising carbon dioxide concentration. And if you put 1 and 2 together, more greenhouse gas means warmer temperatures, and we are indeed adding more greenhouse gas. The conclusion becomes very obvious. We expect global warming to occur, and it is occurring, just as our 1, 2, 3 science says it should. So emphasize to your audiences the science. Even though the climate as a whole is very complex, the basic science of global warming is very simple and easy to understand, and scientifically indisputable. I also like to point out, particularly with my grown-up audiences, where you might have people who think this is some sort of political issue, that the first major global leader to speak out about this and essentially describe the 1, 2, 3 science and say it's a problem was actually the conservative British Prime Minister Margaret Thatcher. Look at what she said here in the speech she gave to the United Nations more than 30 years ago. What we are now doing to the world by adding greenhouse gases to the air at an unprecedented rate is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. You can see more than 30 years ago, no one was saying that conservatives wouldn't talk about this, because conservatives did. And in fact, I believe she was the first major global leader to speak out on this topic. In terms of the consequences of global warming, remember, science, consequences, solutions. Again, with an actual audience where I'm giving an hour or a course, I would spend a lot of time on these. But the key for you is when you're speaking about the consequences, I think it's a good way to present them is in 5 basic categories. And the 5 are that the first consequence, global warming, we usually think of as the general rise in temperature that's going on due to that added greenhouse gas in the atmosphere, but regionally the climate is changing in different ways. Some places warming more than others, some places becoming drier, wetter, and so on. So regional climate change is the first major category of consequence for global warming. The second is the expected increase in storms and extreme weather. Why is that expected? Because the greenhouse gas is effectively trapping more heat and energy down in the ocean, surface, and lower atmosphere. Heat and energy are what drive weather. So as we add more heat and weather energy into the system, we expect to see more severe storms and extreme weather. And of course, we are seeing that signal quite clearly in the data. The third major consequence is the melting of sea ice up in the Arctic Ocean, which is where there's the most extreme regional climate change going on. And that melting of sea ice may sound remote because it's way up in the Arctic, but it has many consequences for the rest of us in terms of changing the weather systems, the jet stream, and perhaps most seriously, the fact that seawater absorbs more solar energy than ice does. Ice reflects more, and therefore this melting of sea ice means we're exacerbating the problems caused by the greenhouse effect, induced global warming, and effectively amplifying that signal. The fourth major consequence, rising sea level, as thermal expansion of the oceans increases the sea level a little bit, and longer term, the melting of glacial ice will add even more to sea level. And the fifth major consequence being ocean acidification. And again, with your audiences, I would encourage you to spend some time on each one of these. For you today, I just want to show you two examples that I find to be particularly powerful with different audiences. The first one, almost everyone will react to this video from NASA showing how temperatures have changed regionally going back to the 1880s. You see the years going by. Blue is colder than the 20th century average. Red is warmer. For a while, there's no clear pattern. But as you start to get into the 1970s and 1980s here, the trend starts to become strikingly clear. And you will typically see your audience's jaws drop literally as they see what has happened in recent decades and realize this is very real. The other example I'll give you here, this one's best for high school, college, and more sophisticated audiences because it involves a bell curve. But this is from James Hansen. And what he did here is he normalized all summertime temperatures over land in the northern hemisphere to a single bell curve, so that normal is sort of typical days of summer, cooler than normal, hotter than normal, extremely cold compared to normal, extremely hot compared to normal. And this is for the period 1951 to 1980. And then he repeats that for more recent times, and he's updated this further since I made this particular graph. And you can see the whole graph has moved a full standard deviation to the right, which means that today's normal is what we were considering hot just a few decades ago. And what used to be considered extremely hot and extremely rare is now quite common. And again, that's something that people are experiencing all around the world with these much hotter summertime temperatures. I want to turn now to the solutions. And again, it's very important to focus on solutions as well as on the problems. And I like to emphasize that there's two basic steps to the solution. The first is we have to stop making the problem worse. The second is we then need to find a way to bring the carbon dioxide levels back down so that we can actually restore the climate to something better than what we are experiencing today and are likely to experience over the next couple of decades. For example, James Hansen has calculated that 350 parts per million would be a good good target. And I want to emphasize, if you think about this and think about that time horizon we talked about before, this means if we were to do both of these things rapidly enough and say by the year 2050 or 2060, you could imagine that for today's kids, they might spend much of their lives living in what you might call a post-global warming world, where not only have we stopped the problem of global warming from getting worse, but maybe we even returned to a better climate. Why do I say it's solvable? It's solvable because we have all the technology that we need to replace fossil fuels already. The existing technologies to replace fossil fuels, I like to break them into three basic categories. Number one is efficiency. You get the same benefit for less energy, less cost. Number two is renewables like wind and solar. Number three is nuclear. And even though some people have concerns about nuclear, I personally think it's a very good idea. But aside from my personal opinion, what's I think very important for us to acknowledge as scientists and encourage our audiences to recognize is it is one of the three general categories of solution that we have today for climate change. So if you think this is a serious problem, this at least needs to be on the table with other solutions. In the future, there's many more technologies that are being worked on that you could imagine us getting. And in fact, while we don't have any of these today, you could imagine that by, say, the year 2050, we might have multiple of these. Imagine having nuclear fusion, for example, in 30 or 40 years, where the amount of hydrogen you get from the water flowing through a single kitchen sink faucet could power the entire United States by itself. There's enormous potential. And that brings me to the way I like to end my talks, which is to get the audience to think, okay, we understand the science and the consequences, and they're very scary. We also understand that there are solutions that we have today and even better ones coming. And that means we can think, instead of a tale of two planets, about a tale of two futures on this planet. And oftentimes it's portrayed in the media as though the choice of our future is between this very grim one where we don't take action and this getting by one where we take action, but things are still going to be pretty tough and difficult. But I think that's the wrong choice to offer. The choice that I think makes more sense is that the status quo is indeed scary. It poses an existential threat to the prosperity we enjoy today in our modern civilization. But the alternative, if we act rapidly enough and do both of those steps, stopping making the problem worse and then making the atmosphere go back to a better state where we get back to a better climate, you can imagine this post-global warming world just a few decades from now, where not only have we solved the problem of global warming, but because those solutions have given us access to low-cost, non-polluting, non-greenhouse causing energy sources, we could do so much more if we act properly with all that energy. And this one, I believe, works with all audiences of all ages. If you're dealing with older audiences, although it does work with anyone, I also like to use this particular strategy to get the audiences to think about how they might deal with this topic. It's what I call a letter to your grandchildren that you're going to seal in a time capsule to be opened in 50 years. Why 50 years? Because that's about 2 generations, which means that on average, your grandkids, if you have them or ever have them, will be your current age. If you're in high school now, you'll have high school age grandkids in 50 years. If you're retired now, you'll have retired grandkids in 50 years. And because in light of all of the polarization that we hear in our society today, there's one thing that I believe everyone from the far left to the far right agrees on, and that's that we all want a better world for our kids and our grandkids. So ask your audience, write this letter. Dear grandchildren, as I write this in 2021, many people are arguing about whether global warming is a real problem. And if so, how serious it will be for you when you were my age. I have examined the evidence and I have decided to, and you write in your decision. Hope your world was a good one. Love, you. I think if we can get everyone to think in these terms, then people will wonder, what will their grandchildren think of them when they open this letter sealed in the time capsule? And maybe in that way, we can get people who might otherwise not think so much about this issue or might even not believe in this issue to really take it seriously and think about what we all must do to solve this problem together. And that's where I will stop. Here again is the same resource page that I showed you earlier. I encourage you to look at these to get further ideas about the kinds of things you can do with your audiences. And I hope that all of you, as astronomers interested in understanding the importance of climate change, will use your public platform and your credibility to go out there and teach other people and help other people recognize the importance of this issue and how we can solve it. Thank you very much.